So here's kind of not just day 2 on graphing quadratic functions, but it's day 2 using vertex form. First off, the essential question, I'm copying what we did last time. We're going to have how do you solve, or how do you graph using vertex form? Let's review some concepts from Friday. So first off, to convert a quadratic equation or function from standard form to vertex form, we've got to complete the square. So standard form, we're going to complete the square so that way it gets into vertex form. So that way we can immediately tell where the vertex is. Vertex is H, so it switches the sign, comma K. So once it's in vertex form, we can immediately plot the vertex on the graph. So because parabolas are symmetrical, we can use the axis of symmetry through the vertex to figure out or some points reflections. To find 2 more points on one side of the parabola, we're going to use an XY t-chart. And then use the axis of symmetry to figure out their reflections. So in order to complete the square, the leading coefficient has to be 1. So let's go to this first example. The bad thing is we need to complete the square to figure out the vertex, but we don't have a leading coefficient of 1. So what we're going to do is let's divide everything by that leading coefficient first. Dividing everything by 2 first, that leading coefficient. Now let's move the constant. And now we're going to figure out, well, what completes that square? I'm going to simplify the left side, rewrite the right side. And now I'm going to try to get this into vertex form. Subtract your constant to the other side, and then we're going to take care of that A. When I say A, and because we divided by 2 in the beginning, let's multiply everything by 2, and when we do that, we're going to make sure, okay, if you multiply this left side by 2, we get just a y equals, when you multiply that binomial by 2, we're going to leave it on the outside. And then multiplying -5 by 2, we get -10. The reason why we want this rewritten is so that way we don't have to do a huge t-chart to see when it's going to repeat, when that t-chart's going to repeat. Now we know when it's going to repeat. The vertex, so now we know the t-chart will repeat around 3. So I can immediately plot 3, -10, produce the axis of symmetry. By the way, when we plug in points, it actually does not matter which equation you use. You could either use the equation of the original form or the equation that you just rewrote in vertex form. But we got to plug in points. So if I plug 5 in, taking 5 minus 3 first, I get 2. Square that, I'm at 4. Times 2, I'm at 8. Minus 10, I'm at -2. Again, check my arithmetic. Once I have 2 points mapped on one side of the axis of symmetry, let's use that axis of symmetry to find the other 2 on the other side. So initially, let's divide everything by -1. So everything's divided by a -1, but then we're going to move that constant to the other side. Going to add 16 to both sides. Simplify the left, rewrite the right. So the vertex form is y equals negative times the quantity x minus 4 squared plus 9. So now we've got a good idea of where the vertex is, where my t-chart should be repeating. And now we see it at, well, what's my vertex? So I'm going to plot it and draw the axis of symmetry. T-chart at 4, 9, it should be repeating. You pick 2 numbers on one of those sides to plug in. And you choose which formula do you want to plug it in at. Whether you chose to plug in 2, 3, or 5, 6, we should have came out with the same outputs. we're going to have to multiply everything by 3. That's the same as dividing by a third, but we'll multiply everything by 3. So if I plug in numbers right by -6, I'm going to get outputs that are fractional. So when I graph them, okay, 2 1/3 is really, really close to 2. But then 3 1/3, all right, that's up 3 and then a little bit more. And then I map them over. My T-chart is not complete, but you could have. If I really wanted to somehow get nice integers, then it takes a little bit. I'd have to figure out numbers that after you square them, I get a multiple of 3. So you either mess with the fractions and graph them, or you plug in numbers that can somehow, after you square them, are divisible by 3. All right, ladies and gents, your homework. Let's start on it. 4 problems, 20, 22, 26, 28. 20 and 22, you have to complete the square, but the leading coefficients aren't too bad. 26 and 28, the equations are already in vertex form, so you're just practicing graphing.